When we do the problems today, you must understand that the transverse axis is what we would call the major axis, and the conjugate axis would be like the minor axis. Okay? So, when we're working with a hyperbola, it says the transverse axis endpoints are 5, 6, and 5, -2. 5, 6 is like right here. 5, -2 is right here. Okay? So the hyperbola would be going like this and like this, because this is the transverse axis. That's the major axis. Okay? The conjugate axis length is 4. Okay? So that's 2 each way. So you have like a little rectangle in here that helps you out to make your asymptotes. Okay. So we have to figure out what the equation is. Well, first we have to figure out where the center is. What's the center of 5, 6, and 5, -2? 5, 2. Okay? The major axis is up and down. So what is positive? Y squared or x squared? Well, if I look at the back side of my sheet, okay, A is always positive, so A is your transverse axis, and so that means your y squared is your positive. So it's going to be y minus 2 squared over the distance from your center to up here. How far is it from 2 to 6? 4. 4 squared is 16. And then with hyperbolas, it's always a minus, and then we'll go x minus 5 squared over, if it's 2y, or basically, if the conjugate axis length is 4, it's 2 wide. So b is 2, so 2 squared is 4, and that equals 1. Okay? So, transverse axis, conjugate axis, A, B. Okay? All right. So generally, I like to, when it's a hyperbola, I like to draw it out a little bit. So I have a bit of an idea of what's going on so I can make my equation easier. Okay? Miss Fellerman, instead of trying to catch up on previous homework, you should maybe listen to this so you can actually understand what we're doing instead of sitting at my desk and figuring it out with me. All right, sounds good. Transverse axis, 2, 4, and 8, 4. Is that a left-right one or a up-down one? Left-right, okay. So if we graph it out, 2, 4 would be about right here. 8, 4 is about right here. So we got it going on like that, okay? So where's the center of this? Not 6, 4. 5, 4. Okay, 5, 4. Here's the center. Is at 5, 4. Now, we go how far to go each way to get to our vertices? 3. So A is 3. Now we got to figure out what B is. Okay? The slope of the asymptote helps us out here. Because here's our asymptote. The slope is rise over run. We go up 4 to the right 3, and going to the right 3 makes sense. So it's 4 up and down and 3 across, so B must be 4. See how the asymptote helps us, okay? So what's our equation? Well, it's this time x minus the x value squared over a squared minus y minus the y value squared over y squared equals 1. Okay? So we just have to take what we're given to make the equation. The next one, the foci are at -5, 3, and 1, 3. The transverse axis is -4, 3, and 0, 3. All right. So -4, 3, and 0, 3 are like right there and there. Whoops, didn't quite hit it. There we go. And the foci are on this side of it. So obviously it's going to be a left-right axis, left-right one. Okay. Where is our center at? Halfway in between -4, 3 and 0, 3 is what, Carson? Could you pay attention, please? Yeah. What's halfway in between -4, 3 and 0, 3? -2, 3. There we go. That's where our center is. Okay. All right. Now, on your cheat sheet, what does it say for our Pythagorean little relationship for hyperbolas? C squared equals a squared plus b squared. C is our foci length. So from -2, 3 to -5, 3 is 3, right? So C is 3. A, the distance between those two is 2. So we got to figure out B. So 9 equals 4 plus b squared. So b squared must be 5. Do I have to write b as the square root of 5? Not when I'm making an equation, because it's x minus the x value squared over a squared minus y minus the y value squared over b squared equals 1. Okay? So it depends on what they give you. The first problem gave you both axes. The second one gave you an asymptote to help you find the other one. The third one gave you foci to help find the other one. Okay? So it all depends on what they give you to figure out your equations. All right, continuing on. Now they give us the equation, you got to find everything else. Well, this is actually pretty easy. Okay, where's the center at? -3, 5. Very good. Okay, the vertices are on the major axis. They're how far away from your center? 5. So is this an up, down, or right, left? Up, down. So we go 5 each way from here. So your vertices are at -3, 10 and -3, 0. Your foci, c squared equals a squared plus b squared. 5 squared plus 12 squared, which is 25 plus 144, which is 169, which is 13. So the foci are 13 away each way. Okay? So the foci are at -3. If we add 13, we're at 18. And -3 and -8. Okay? That one's the same thing, so I'm not going to do that one. For this one, if you see an equation like this, what should you do? Make sure it equals 1. So it's x squared over 10 minus y squared over 1 equals 1. Okay, get it equal to that right away. Okay, what's the focus? Okay, well, the focus, c squared equals a squared plus b squared. This is already a squared, that's already b squared. So c squared equals 11. So c makes equal the square root of 11. Which one involves the square root of 11? That one right there does. Okay. And then, what's the center of this one? What do we have to do? Complete the square. 9x squared minus 36x plus blank minus 10y squared minus 20y plus blank equals negative 116. Okay, so if we factor out a 9 from this one, we get x squared minus 4x plus blank. If we factor out a negative 10 from the second one, we get y squared plus 2y plus blank equals negative 116 plus blank plus blank. What's half of 4? 2. 2 squared is? What's 9 times 4? 36. So we're adding 36 to that blank, because really this blank is 36 because it's 9 times 4. What's half of 2? 1. 1 squared is? So this is negative 10 we're adding to here, so it's negative 10 right here. Okay? So negative 116 plus 26 is negative 90, right? Okay? So if we take 9 times x minus 2 squared minus 10 times y plus 1 squared equals negative 90. We divide by negative 90. Then we get negative x minus 2 squared over 10 plus y plus 1 squared over 9 equals 1. So your center is at opposite, 2, negative 1. Okay, those are the types of problems that you'll see today. Actually, those are the 7 problems that